Hello all, welcome back to this session. Today we will be talking about assessment of thermal environment. We are talking about the evaluation of workplace, so ergonomic workplace evaluation. So when we are talking about ergonomic workplace evaluation, environment, physical environment is very important component in terms of performance, productivity or the kind of design we have around. Okay. So, if we understand the some concepts of thermal environment, how we can measure them, how the impact is there of the thermal environment on us, and what are the varieties of comfort expressions or sensitivities are there, then it will be very easy when we are talking about the physical environment in ergonomic workplace evaluation. So, today's topic is how we can do the assessment for thermal environment. So, let us first understand what it is. So, thermal environment has a major influence, as I mentioned earlier, on the performance. Okay. So, if you can easily understand this one from your own experience. So, if the environment is not conducive or not comfortable in terms of heat, then we feel discomfort, and discomfort definitely affects your performance, sense of well-being, right, when you do not feel good. So, when we are talking about health, like suppose we are working or as this whole topic is on the occupational health, like ergonomics workplace. So, workplace depends when we are working. So, when we are working in a particular kind of extreme environment, definitely that has an effect on the physiology, what we discussed in earlier days. So, on the physiology, if it is affecting, then the whole physiological system, maybe digestive system, maybe respiratory system, they will have an effect. So, it will affect the health. So, major factors that influence people's thermal comfort, that is, if the environment is too hot or too cold, then there will be a problem. So, the ambient conditions such as thermal environment, interior layout, building structure, it always has an effect on the total experience. There also, these are the first what we talked, that the ambient condition, environment, interior layout, these are the physical factors present in the workplace. But something which is personal, like your own physical fitness, your own psychological status of that current situation or that particular situation, that also has an impact or has a relation with the thermal environment or thermal comfort basically. So, within certain limits, the human body can adapt the changes in thermal environment depending on the person's metabolic rate. So, what is metabolic rate, that we will be talking later. When we are talking about thermal environment like heat and how it is getting balanced, we need to really understand what is the heat balance we maintain in a particular workplace or in surrounding. So, it is very simple, that S, what we call at this heat storage of the body, is equal to M, that is means metabolic heat production, like heat generates within our body. So, that is the source of energy, right, source of heat. So, from that different subtraction of sources like W, that is the external work, minus C, that is the heat loss by convection, minus R, that is the heat loss by radiation, ESK, that is the evaporation heat loss from your skin. So, many times it happens when we are working, we discuss this one during our physiological fundamentals of physiology, that some perspiration continuously happens from our skin that we do not understand, and something is the sweat absorption. So, that also separate. So, that is one. Then CRS, convective heat loss from your respiration, ERS, evaporation heat loss from respiration, and K, that the heat loss by conduction. So, this is the basic heat balance mechanism or heat balance formula that our body follows. So, that is very important when we understand the thermal comfort and the available heat within surrounding. So, when we are talking about thermal environment or thermal physical environment, thermal indices is a very important nomenclature or very important aspect what we always measure and compare. Okay. So, what these are? This is a very useful tool for describing, designing and assigning thermal environments in the thermal index, right. So, principle is that factors that influence human response to thermal environments are integrated to provide a single index value. So, whatever the components are there within the environment as far as thermal is concerned, we are translating them into a single index value, which is very easy then to compare or to use further. The aim is that the single value varies as human responses varies. Like if the indices is on the higher side or on the lower side, my responses towards thermal environment will also change accordingly. And this can be used as to predict the effects, because suppose some index says that if the index value is lower than this particular point, then we are prediction is the human being in normal condition will feel comfort. So, if we understand that index value or if we measure the index value, we can predict the person who is working in that particular location or particular work environment will feel comfort and the performance or productivity will be as expected. If there is change or there is some difference in that phenomena, maybe we need to look into or look back what is the problem. So, it really helps, this indices really helps to understand those critical criteria or critical points where ergonomic evaluation need to start. So, a thermal comfort index for example would provide a single number which is related to the thermal comfort that I was talking earlier of that particular occupation of a particular environment, right. So, suppose a person working in a, maybe we can take an example like fish processing industry, right. So, lot of cold, the temperature around surrounding temperature is very cold. So, what if we understand the index, a particular thermal index over there, then we can find that how long the person is comfortable to do their job in that particular index. Okay. So, based on that maybe we can decide on the work rest cycle, or maybe we can decide on the what kind of clothing we should give so that comfort level can come back. Okay. So, these are the decision making point we choose when we are talking about the thermal indices. So, let me tell the rationale of these indices. So, rational thermal indices are developed with the help of heat transfer equation, what we discussed earlier, that heat balance and heat transfer equation, and in some cases mathematical representation of physiological thermoregulation, right. So, physiological thermoregulation we discussed that how it happens through our hypothalamus and all these physiological phenomena like ATP transfers to translate to ADP, and then heat generates, there is metabolism happening through that, heat generates, all these calculations. Okay. These are used to predict human responses in various thermal environment. Let us take an example. A index to determine how wet the skin is, maybe the index we can call W. W is equal to E divided by E max. What is W? W is the index of skin wettedness, right. How wet my skin is. How we can calculate that? E divided by E max. E means actual evaporation rate. So, what currently is happening divided by E max means how maximum evaporation rate can be. So, based on that, so if it is the actual one is tending to the maximum, then I will understand my skin is going to dry. If it is not happening, it is less, then maybe there are some accumulation of humidity on my skin. So, I will feel little wettedness. Right. So, these are some indices that can help us to understand the comfort, as well as it will help us to understand, it will not give direct measurement, but it will help us to get an idea how the performance and productivity is getting affected, or is there any scope of design intervention to improve the situation or not. So, when we are talking about empirical indices, these are developed based on the data collected from human participants exposed to a long range of environmental conditions. Okay. So, it is not that all of a sudden someone can develop that, it needs real long exposure and lot of other calculations. Some examples are wind chill index, some are comfort index, and there are many others. We will be discussing few of them. Now, when we are talking about thermal index or thermal indices, one very important index is WBGT index, wet bulb globe temperature. So, what it is? It comes under the direct indices. So, what is direct indices? Direct indices are measurements taken on simple instrument. It is very important criteria, that is the simple instrument. So, we may not have a facility to measure lot of critical components or critical variables, but if we have some simple instruments that we will name them. So, if we have that, maybe we can have a good idea about the thermal impact or thermal environmental impact on the human body. So, one of them is WBGT index. So, for measuring the WBGT index, we only need a dry bulb, a wet bulb, and a globe thermometer, which is very easily commonly available, and every workplace we can use these three instruments to identify or to measure the WBGT index. It has a specific formula. I would request you to look into the books and find out and measure your own WBGT index wherever you are working, or you can do some evaluation based on your idea or your understanding your surrounding physical environment, and find out the WBGT index of that particular location. One more important component is effective temperature. It is also very much useful and commonly used in this index. So, what it is? It says is often used as an estimate of a body's surface temperature. Okay, it try to measure the, not measure, it gives an estimation of the surface temperature when body's emissive curve is not known. So, what it does? It is defined as the temperature of a still and saturated atmosphere. Very important assumption is the still and saturated atmosphere, which would in the absence of radiation produce the same effect as the temperature in question. So, a particular temperature we can test it in different situation. So, effective temperature cannot be measured by a thermometer. It is an experimentally determined index of the various combination of dry bulb temperature, humidity, radiant condition, and air movement that include the same thermal sensation. So, it is not only measurement of some physical environment, it includes the sensation as well. That is why it is effective temperature, and it talks about the surface of the skin. Okay. So, very much important when we are talking about thermal comfort, performance, productivity, and all those relevant topic. So, effective temperature is very useful index in industry, and we practice it to understand and measure when we are talking about thermal comfort. So, as we are talking about indices or thermal indices, let us talk about thermal comfort, because physical environment, physical thermal environment has a direct impact on the sensation. So, the sensation or our perception is only the thermal comfort. So, what it is? Thermal comfort is the condition of mind that express satisfaction with the thermal environment and is assessed by subjective evaluation. Okay. So, it is not a measurement, it is a subjective evaluation. So, it is defined by different standards, especially ANSI or ASRI. Okay. So, maintaining the standard of thermal comfort for occupants of building or other enclosure. So, when we are in within a surrounding is one of the important goals of HVAC design engineers. So, what they does? They try to achieve that all the occupants of that particular room or enclosure should feel comfort. To understand that, they need to understand what the thermal comforts talks about. So, basically this thermal comfort depends on the different indices, that components like air velocity, air temperature, humidity and all those things. Most people will feel comfortable at room temperature, which normally ranges from 20 to 22 degrees centigrade, but this may vary greatly between individuals and depending on the factors such as activity level, clothing, humidity, etc. Okay. Take example, if the air temperature or the effective temperature of that particular, not effective, if the temperature of that particular room is some degree centigrade, suppose 20 degree, and someone is wearing a very thin cloth and someone is wearing woolen sweater or something, definitely the comfort level will change, comfort level will vary from one person to another person, right. So, this talks this thermal sensation or perceived comfort is very important to understand when we are designing the interior. Why this is important? Of course, we are talking the same thing. So, we say that if 75% of all occupants within the building are thermal are telling that it is thermally comfort, then it becomes very easy to say the environment is good. The thermal environment has been shown to have up to a 10% effect on the workers' productivity. We are not very sure, or it is not very easy to directly measure that what is the percentage of impact, but still it has been identified that it is almost 10% or it can go up to 10%, and of course, it depends on the energy consumption. Satisfaction with the thermal environment is very important, as thermal conditions are potentially life threatening for humans if the core temperature reaches the condition of hypothermia or hyperthermia. So, what is hypothermia? Hypothermia says that when your core body temperature goes down till 35 degree centigrade. Hyperthermia when it crosses 37 or 38 degree centigrade, then there may be a case of different physiological malfunction, may be a fatal case. Okay. So, if we do not understand the thermal comfort, it becomes very difficult to take decision in case of hypothermia and hyperthermia. So, buildings modify the conditions of the external environment and reduce the comfort that our body needs to do in order to stay stable at a normal human body temperature. That is the designer's role. So, important for that the correct functioning of our physiological processes. Why we need that core body temperature on a constant position? Because it helps us to function, that physiological functions run in smooth way, right. So, that needs to be done. So, thermal comfort has also been known to lead to stick building syndrome symptoms. it also a very important sick building syndrome. We call it it's very common phrase, but determining that is very difficult. So, the combination of high temperature and high relative humidity serves to reduce thermal comfort and indoor air quality. So, when we are talking about thermal comfort, we understood the thermal indices, but definitely thermal comfort is the causal factor of many other things, right. So, we should know what are the influencing factors available which actually affect the thermal comfort. So, there are three major factors. One is environmental factor, personal factor and contributing factor. Now, these divisions are made by the ANSI and ASHRAE standard. There may be some changes in the terminology by different other researchers. So, for the environmental factor, air temperature, air movement, humidity and radiation we will be considering as per the ANSI standard. Personal factor, metabolic rate and clothing. Contributing factors, food and drink, acclimatization, body shape, subcutaneous fat, age, gender and state of health. These are being defined by the ANSI and ASHRAE. So, let us understand what these are. So, air temperature. Air temperature is the most important environmental factor measured by the dry bulb. Okay. So, when we are talking about air temperature, we will be talking about the measurement of the dry bulb. This will determine the convective heat dissipation together with any air movement. In the presence of air movement, the surface resistance of the body is much reduced. That we need to understand, because if you have a clothing there, then perceptions or comfort will be different. Then the next parameter or variable is air movement. So, based on the air movement, your perception or your comfort level changes, and how we measure it? We measure in terms of velocity. So, meter per second, normally we can translate it according to our requirement as well. Now comes under humidity. What it is? It is absolutely depend on the how much water content we have within the environment. So, normally we calculate this one as the relative humidity. Then one more important factor is radiation. So, radiation exchange will depend on the mean temperature of the surrounding surface, referred to as the mean radiant temperature, MRT. So, this particular variable is an important measurement when we are talking about the thermal environment. The MRT cannot be measured directly, of course, but it can be approximated by globe temperature measurement. Okay. The globe temperature is a mat, what is dry bulb, wet bulb and globe temperature. These three thermometers are very important when we are talking about the thermal environment. So, what this globe thermometer is very important. It is a black copper sphere and usually of 150 millimeter diameter with a thermometer which is located exactly at the center of the globe. Now, when we are talking about other contributing factor, major is metabolic rate. Okay, that is the source of the heat within the body. So, people have different metabolic rates that can fluctuate due to activity level. Okay, very important, because if you run, definitely heat production in your body will be different, but if you are in a sedentary job, the production rate will be different. So, environmental condition also. So, if you are in a cold room, that metabolic rate will change. Metabolic rate is expressed in MET unit, MET, okay, which can be defined as 1 MET equal to 58.2 watt per meter square. So, these are the calculation that you need to do when you are specifically calculating the thermal discomfort, thermal comfort and presence of heat within the environment, and how the human being is interacting or reacting on that particular aspect. So, this is ASTRI standard. Some of the activities is being already calculated and mentioned by them. So, you can refer this table directly, or based on the requirement you can calculate as well. When we are talking about thermal comfort, we already spoke about what kind of heat we have within the environment. Now, thermal comfort very much dependent on the clothing pattern, right. So, we say that it is an important on the dominant factor that affect heat dissipation. Okay, the heat will go out from the body. So, how the insulation is, so very important, and it is being always presented this particular clothing factor as CLO value, CLO, CLO value. So, it has every fabric has their own CLO value. Based on that we can decide what kind of insulation we have within our body. So, this corresponds to an insulating cover of the whole body of transmittance of 6.45 watt per meter square K. Amount of insulation that allows a person at rest to maintain thermal equilibrium in an environment at 21 degree centigrade in a normally ventilated room we consider as 1 CLO. There are a number of ways to determine clothing insulation provided by clothes, but the most accurate according to ASTRI fundamentals are measurements on heated mannequins and on the active subjects. So, definitely we can get these measurements done. So, let us understand some of the measurements. So, what are the measurement device criteria? The measuring instrumentation that is defined by ASTRI need to be used shall meet the requirements of the measurement range. So, what is the whole range can be possible, it should measure that, and accuracy given in ASTRI standard 7.705 or ASTRI standard 1136 or in ISO 7726. These are the standards you can follow and you can get the measurement device criteria. So, when we are talking about measurement, let us understand where we should measure it. So, measurement location, position. So, measurement shall be made in occupied zone of the building at locations where the occupants are known to or are expected to spend their time. It is not that this whole the whole room is occupied by one person and the long room the other corner no one is there. So, where do you measure? You will be measure only the location where the occupant is. If that is not being defined or you can't find that, then what you should do? You should measure it at the center of the room or the center of that particular zone. 1 meter inward from the center of each of the room's wall. In the case of exterior walls with window, the measurement location shall be 1 meter inward from the center of the largest window, because these are the sources of difference in the environmental heat, right. Wind position can change the wind speed, then window position will change the wind speed. Also, it may give some other external heat within the room. So, these are the things we should maintain when we are talking about the measurement location. At which level we should measure, like height. So, air temperature or air speed shall be measured at the 0.1, 0.6 or 1.1 meter levels for sedentary occupation if the person is in seated condition. Same thing will vary if the person is standing. So, that will be 0.1, 1.1 or 1.7 meter. So, operative temperature or PMV PPD shall be measured or calculated at the 0.6 meter level. For seated occupants, if it is standing, then 1.1 meter level. Radiant asymmetry, always we need to measure at the 0.6 meter if seated, if standing then 1.1 meter. Humidity also we follow the same position. Now, when we are talking about measurement, we talked about thermal comfort. Very important is how we should gather data as per thermal comfort is concerned. So, definitely it is a subjective approach. What it is? So, subjective approach is basically aimed at finding out the judgment about the perception of the thermal environment in terms of acceptability or preference of colder or warmer environments. So, we have one very standard used scale, that is the ASHRAE 7-point thermal sensation scale, which I mentioned here. So, in the neutral point we call it as 0. Once we go on the side, like on the left hand side, it keeps on getting like cool sensation, cold sensation. Here it is heat sensation. So, very important frequently used scale is this ASHRAE 7-point thermal sensation scale. Now, this I am not going to elaborate, but if required you can go into detail, and if you have any further question you can come back, we may answer your queries. So, PMV PPD index is very important aspect. We call it as thermal comfort model, and we see where this PMV is located. So, this 0.0 is very important, how the PPD percentage is increasing on this side and how it is increasing on this side. So, this model I am not going to explain very in detail, but you can follow this one. If you have query you can come back. Now, when we are talking about PMV and PPD index, so this, can you see this one? This is very important, that this whole zone, okay, this whole zone we call it as comfort zone. So, psychometric or temperature relative humidity chart. So, again it is by ASHRAE 55 or ASHRAE 55. So, what it says, that if your comfort level lies within this zone, you are safe. If it is outside, then you are not in the comfort zone. Now, concern is this particular phenomena, this whole particular phenomena is not globally true, right. So, the phenomena is true, phenomena is true, but this temperature ranges, these ranges are not true always for every context. Based on the context, this zone changes, and it may go on this side, it may go on this side. So, based on your understanding, your requirement, you need to establish this particular zone, and you have to find out where your comfortable zone is, because comfortability again or comfortness again depends on the adaptation capacity or habitual activities, right. So, those are important aspect. Now, very important discussion is local thermal discomfort. What it is? According to ASHRAE 552010 standard, there are 4 main causes of thermal discomfort to be considered. A section of the standard specifies that requirements for these factors that apply to the lightly clothed person engaged in near sedentary physical activity. Okay. So, this is because people with higher metabolic rate and or more clothing insulation are less thermally sensitive, because they are not in touch with the direct environment and consequently have less risk of thermal discomfort. Okay. but based on the context these phenomena definitely will change. Now let me talk little bit about the standards. We have varieties of standards. So ISO ASHRAE 55, it says about the thermal environmental conditions for human occupancy. ISO 7993, it talks about hot environment, analytical determination and interpretation of thermal stress using calculation of required sweat rate. Okay. So, these are mainly on the thermal comfort. We have something for the indoor thermal environment, that is ISO 7726. It talks about the ergonomics of the thermal environment, instruments for measuring physical quantities, and ASHRAE 55 that also talks about thermal environmental condition for human occupancy, which is same. Now, there are some standards which deals with the design of the indoor environment, like ASHRAE 62, ventilation for acceptable indoor air quality, CR 1752, ventilation for buildings, design criteria for the indoor environment. Standards for determination of the personal factor, like ISO 8996 that talks about the the chapter name is ergonomics, determination of metabolic heat production, and ISO 9920 that is the estimation of the thermal insulation and evaporative resistance of the clothing ensemble. When we are talking about all these aspects like thermal discomfort, thermal comfort, thermal temperature indices measurement and all those things. So, practical assessment of thermal environment is very, very important. So, this particular principle provided, this particular principle whatever we are following for the practical assessment can be used to develop a practical methodology to assess any thermal conditions based on the human responses, what you can do yourself. However, if you see through the literature, there is no globally acceptable which is applicable for all contexts, that kind of methodology is not being established till now. So, based on your context, you need to really develop your own methodology and you have to work on. When we are talking about measurement or assessment, we can have three variety: hot, moderate and cold. So, for hot environment measurement or not measurement, assessment, so evaluation of comfort and stress, we can go for WBGT index, which is being mentioned in ISO 7243, and WBGT required sweat rate. This is again some modification in 7933, that is also ISO. Physiological strain evaluation, what it is? So, mainly the core and skin temperature, heart rate, mass lost, sweating and respiration. Psychological strain evaluation, subjective assessment method. So, and the surface temperature, which is being mentioned in ISO 13732-1. So, this you can have understanding when we are talking about the hot environment assessment. Now, if we are talking about moderate environment assessment, predicted mean vote and predicted percentage dissatisfied. So, which we already spoke about that model that is being presented very in detail, ISO 7730. Physiological strain and evaluation, again the same, core and skin temperature, heart rate, mass loss, sweating and respiration. Subjective assessment method and surface temperature. And cold environment, same, wind chilled index, what I mentioned in the very first slide. Then physiological, same again, core, skin temperature, heart rate, mass lost, sweating, respiration, etc. and subjective assessment method and surface temperature, which is depicted in 13732 part 3. So, the previous one is part 2, the first one is part 1 and the third one is part 3. So, this way you can assess. So, see, all these whole course will be talking about different application and the assessment criteria. So, detailing is not possible, but of course, when you are talking about all this assessment measurement, you can practice yourself, you can generate your own methodology, you can inquire back with me for better clarification. So, this is one of the book what I ask you to refer if you want to know more. Also, there are varieties of literature available which will help you to understand and explore more about the impact of thermal environment on the performance and productivity, and how that the it is relevant or it is related to the ergonomic workplace evaluation, and if how we can take those key points to design or design modification or the thermal environment changes. Okay. So, what will be the instruction for you is, whatever we discussed today, please take each point, practice it at home, find out what are the varieties or possibilities are there in your research area, and if you have any query, come back to me for better clarification. Thank you.